Hello, my name is Rob Reynolds, and welcome to Mat-073, where in this lesson I'm going to kind of do an extension from section 3.5. In section 3.5, we were learning how to solve systems of equations, and something like this, and we did first of all by the graphing method, then we did by the substitution method. The last video I did was solving by linear combinations, or the elimination method. And so I'm going to show you how to check your answers on your calculators. So the first thing I need to do is give you a little mini lesson on what a matrix looks like and how to define it. So basically the matrix is not like the movie. We're just going to drop the coefficients. So instead of x's here and y's here, I still think about an x column and a y column. But then I just put an answer column over here. So instead of an equal sign, oftentimes you'll see this bar here, or this line, which represents those are the answers. So this is your x, this is your y, this is your x, this is your y. You just drop the variables. But the matrix just looks like 3, 4, 1, because there's a 1 in front of that x, and a negative 2. And then this goes the answer. So this is your x, this is your y, and these are your answers 5 and 1. So the next thing I need to talk to you about with matrices is rows and columns. And I don't even know if they make RC colas anymore, but I always teach this row by column. So matrices are always row by columns, never column by rows. And rows always go left and right, and columns are up and down. And the way you can remember that is, how do you spell columns with a big up and down arrow? So the rows are going this direction. So for example, this is a 3 by 4 matrix. This is a 3 row, because there's row 1, row 2, and a row 3 matrices. But 1, 2, 3, 4 by 5, and this is a 1, 2, 3, 4, 5 by 2 matrix. So you need to know how to find the dimensions first of all. And when you're multiplying, we could talk to a whole lesson about how to multiply matrices together and add and subtract, but I don't want to get into all that. Here's just the dimensions, because we don't need to add and subtract matrices to solve a system. So this one is a 3 by 3 matrix, or a square matrix sometimes. So here are the directions. You could probably pause the video and copy these down, but these are the steps that we're going to be doing in the examples. I'm going to explain them as we go through the video. So if you pull up your calculator, here's the first matrix that we're going to type in. 5, negative 4, negative 2, 3, and 2. So it came from this system, but this is called the matrix. So go to your calculator, and the first thing it says to do is hit second matrix, which is that x to the negative first key. And a second just means it's buried. It's not a first ordered function. It's the little words above the first ordered function. So your calculator will look like this. Hit the edit key, so slide over to the arrow to the right for edit. And we're going to edit matrix A, and of course you could edit matrix B as well, but all I need to do is matrix A for now. We're going to define the given matrix like a 3 by 4, and this is actually a 2 rows. So there's row 1, row 2 by 3 columns. So I'm going to, in my calculator, put 2, enter, 3, enter to define the matrix 2 by 3. Then I'm going to enter the elements. 5, enter, negative 4. Now be careful, the negative key is the white key. Don't get confused with the minus key, which is gray. You have to type in the negative key down here. This is for the negative 1. Your matrix won't work if you type in a minus 1. So negative 2, 3, and a 2. So this is kind of confusing. Once you edit your data values, then you're going to go back and hit quit. This is a really important step. Step number 4. Students forget to do this. You have to get out of that matrix function to only get back into it. It seems unreasonable to do that, but you get out of the matrix to go back into the matrix. To go to mathematics, which is step number 6, and then it says arrow up to reduce row echelon form, RREF, and that's letter B. I'm going to press enter, which actually there should probably be the word enter right after this. And then we go back to second matrix for the 3rd time. So you're actually going to hit second matrix 1. Whoops. That's not second matrix 2. 3 times. for this process. So the third time, second matrix, I'm going to press enter because it is under matrix A. If it was under matrix B, I would just choose 2 and then press enter, or matrix C, press 3, enter, and then enter again. So this gives me these long stringy decimal answers, so I would hit math, enter, enter, and see if I could convert that to a nice fraction, which it does. So this is a much better answer, 5/7, 8/7. I do not want to mess around with terrible decimals, because I would never know what to round to. So exact answer is 5/7 and 8/7. That works for me. Let's try it again. Sometimes we have matrices that we need to add zeros to. So row number 1 is 2, -1, 4, and the answer is -3. Row number 2 has a 1 here, and actually no y's, and you need a placeholder for that. Otherwise, you will not be able to solve for the correct answer. So I'm going to fill in the rest of these. This is a 1, 2, 3 row by 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. So I'll go edit my 3 by 4. Second matrix, edit, 3, enter, 4, enter, 2, enter, -1, enter, 4, enter, -3, enter. This is very hard to do on the computer. You're going to be more successful. 0 is the point of this whole problem. Enter that placeholder. 6, -1, 2, and 10. The important part is hit second quit. I'm going to go, I'll show you a trick. The second time you do this, instead of going all under this is a nice trick. Just hit second enter. It's a recall key. I'm going to hit second enter again, and I don't have to do RREF because it's already kind of stored. So you can always hit second enter for a recall feature and then just press enter. So I have a new matrix under there, and so it's now finding the reduced row echelon form for my new matrix. So just to explain this answer just a little bit, why is this a solution? This is a solution because if we were to dump this back into a system form, this top line would say 1x plus no y's plus no z's. In other words, just 1x would equal 3. And this bottom line would read z equals -1/2. So you can actually write your answer in an ordered pair, 3, 7, -1/2. And there's example number 2, 3, 7, -1/2. This next example I actually stole from a previous lesson. I know the answer is no solution, but I wanted to show you what that looks like on your calculator. So it's an easy system. We could actually just multiply the volume equation through by -1 and solve this by systems. But again, I wanted to show you what this looks like on your calculator. So I'm going to edit this matrix. This is going to be a 2 by 3 matrix. And I'll enter 2, -1, 1, 2, -1, and -3. And I'm going to second quit to get out of that. Second enter is a recall for the answer. And look at this bottom row. This is what I want to talk to you about. Be careful, because some students will say, well, the answer is 0, 1. But if you're reading the bottom row matrix carefully, it actually says 0x plus 0y equals 1, which means 0 equals 1, which, if you remember, is a false solution. And if it's a false solution, then it's the empty set. So here's the actual slide from several lessons ago. So 0 does not equal 4. This is working it out through the elimination method. So remember, there's no solution, or the lines are parallel, and there's empty set. So the last example is the opposite of the empty set, which would be infinitely many. So I wanted to show you what that looks like. So again, I'm going to go back to editing my matrix. Still a 2 by 3. 3, 4, 5, 9, 12, and 15. And second quit, and again, instead of using all that, I'll just hit second enter. Assignment, kind of nice to do your whole homework assignment at the same time. I'm going to hit math, enter, enter again, because I can't stand those long, stringy decimals. So that cleans it up. Math, enter, enter will convert it to a nice fraction. And then looking at this solution, again, you might think that the answer is 5/3 and 0, but read that bottom row, which says 0x plus 0y equals 0. And actually, that's a true statement, and true statements are not the empty set. True statements are infinitely many solutions, which means everything on the first line, line A, also is a solution for line B, because all those points are, and there's infinitely many points on that. So again, if it's a true statement, then you say infinitely many solutions. So it's a dependent system, and infinitely many is a solution. I hope this video was helpful. Email me with your questions. Thanks.